Okay, this section is going to look very similar to the things we've done before, with the few exceptions, and they're not too tough, but you'll want to pay close attention to how we work them. Let's take a look at our first one. And I might have to erase stuff as I go along, so we'll see. I have x minus 3 is less than 5. You know what I'm going to do? I'm going to do it over here, just in case. X minus 3 is less than 5. If this were an equal sign, let's say that it was x minus 3 equals 5, we would know exactly what to do with this problem. We would know that adding 3 to both sides would be how we would isolate the variable, and so in this case, x would equal 8 in a problem from a previous section. All stuff that you guys have done many times. This section has its first difference in that we use inequality signs in place of equal signs. And we'll see what that means in just a moment in terms of how to interpret the solution. But the way to solve it remains very much the same. You would still add 3 to both sides, but instead of x equaling 8, x would be, in this case, less than 8. And we know how to read inequalities because we've done them before. You read them left to right. X is less than 8. And so that is the answer. We would put in here, x is less than 8, and that would be your solution. Now, in terms of selecting the correct answer, this is the second area that is new to this section. And what I'm going to do is give you some notes so that you know how to handle this. First and foremost, if you do not see an equal sign, and these are some things that we talked about before, if we just have a less than or a greater than sign, that is going to lead us to use an open circle on our graph. So a less than or greater than sign, less than, greater than, will lead us to conclude that we must use an open circle. So that means that A and B are not options for our answer because both of those use closed circles. Now, while we're on the topic, we might as well address what would cause a closed circle. Well, if you saw a less than or equal to, greater than or equal to, that would warrant the selection of a closed circle or using a closed circle to graph the endpoint of your line, okay, or your shaded line. So as you can see here in our answer, x being less than 8, it does not have an equal sign on it, therefore we do not use the answers with closed circles at their endpoints. So now the next question is, between C and D, which is the correct answer? C is going to the left. All answers are going to negative infinity. D is going to the right. All answers are going to positive infinity. Well, let's go and read this. All answers should be less than 8. And if that's the case, D cannot be correct because D is all answers that are greater than 8. C must be the correct answer. Are there any questions about number 11 or your number 11? Let me know. Okay, all right, let's go to the next problem. Now, in this next problem, I want to once again draw a parallel to problems that we had done in the past. And so in the past, what we may have seen is something like what is on the left there. 3x equals 21. In the past, if I gave you this, a previous section, you would divide both sides by 3, and x would equal 7, and that would be your answer. However, as we stated in the previous problem, this section differs because it uses inequality signs. But that does not change the method used to obtain the answer. And so I would still divide both sides by 3 to isolate the x, and I would carry down the inequality sign. And so my answer would be x is less than or equal to 7. And you can use your palette down here to select the less than or equal to. Did I say 7 or negative 7? Should be negative 7. I forgot my negative sign here. That was a negative 21 divided by 3, which is negative 7. Let me put that correctly. There you go. Okay? So you've got your answer there. Now let's select the correct graph. Now recall from the previous problem that we stated in our rules that if we saw less than or greater than, it would be an open circle. Well, this is not just a less than or greater than. This is a less than or equal to. That means that in this case, B and C, for me, are out of the question. They're out of the question because based on our key, our very important key, this is a problem that should use a closed circle. Closed circle, and this B has an open, and this C has an open. Now, let's determine whether we need to go to the left, D, or go to the right, A, of our closed circle at negative 7. Well, if we read this left to right, this is saying all of my answers for x should be less than or equal to negative 7. And of course, less than or equal to does not go to the right. Less than things go to the left. And so D would be our correct answer for this problem. Any questions about that one? Okay. Number 13. (4x minus 1) is greater than 31. Once again, I'm not going to do this all class long, but I'm going to show you the comparative problem, similar problem that you would have seen in, comparable problem that you would have seen in previous sections. In previous sections, you would have seen 4x minus 1 equals 31. You would have added 1 to both sides, and that would have given you 4x equals 32. Then you would have divided both sides by 4, and x equals 8. And that would have been the answer in a problem like that one. Now, of course, our problem is very similar, with the only exception being that we're dealing with a greater than inequality sign. But when that's the case, it doesn't change your approach. Your approach is still the same, with the exception being that you're dealing with or working with an inequality sign. So I do the exact same steps, the identical steps as I would have if it was an equal sign. The only thing I change is I carry an inequality sign with me through the problem. Okay? Now, which is the correct answer? Well, let's take a look here. First and foremost, this is a greater than. Since it's a greater than, using our key, we should not have any answers with closed circles in them. That eliminates A and C as potential options for our problem. Well, between B and D and potentially even E, none of the above, what does it have to be? Well, this is saying all answers are greater than 8. And greater goes to the right. And so therefore, oh, did I? Yes, I got that. D is the correct answer, B is not. Obviously E is not, so D is correct. Okay. When you look at D, it's kind of hidden behind here. Open circle, greater than 8 to the right of 8. Got it? All right, let's keep going. All right, solve the inequality and graph the solution set. All right, now we have actually seen this one as well. I'm going to come back to the top here, and I will again do this one as a problem like we've seen in the past. So my current problem is x over 2 is greater than negative 3. In the past, even just 2 days ago, it would have been x over 2 equals negative 3. That would have been the comparable problem to what we just did. How would we handle this? Well, recall that we would have multiplied both sides by the denominator of our fraction, left off over there. So as you can see here, the denominator's a 2, I need to clear out the fractions, so I'm going to multiply everything by 2. And so in the past, this would have canceled it, leaving you with just x equals negative 3 times 2, negative 6, and there would be the answer. Well, the same is true here. These cancel out, leaving you with x is greater than negative 6. And so that is my answer. Now, at this point, I'm not going to continue justifying these answers. X is greater than negative 6, that would be A for me. I think that you guys pretty much understand how to graph at this point, and you're probably getting a lot better at these inequality solutions. Questions at all? Okay, 15. Now, 15 is one in which we do need to discuss a very, very important topic, and it is a rule, and it is the third item that is unique. I believe the third and final item that is unique in our discussion of linear inequalities. Some of you may already know what is going to happen here. So I have negative 4x is less than 8. When you have that, if we did it in the past, like our previous sections, we would have divided both sides by negative 4, and x would have equaled negative 2, and that would have been the correct answer. That's nothing new, that's not very difficult, and it's certainly something that you can do as well. However, while you would still divide by negative 4 in our inequality scenario, there's one very important thing you must do when you divide by a negative. And I'm going to put this rule right up here. If you happen to divide by a negative, you must flip the inequality sign. And that is the third area that we have to discuss. And that's what we've seen here. So if you put and just carry your sign down, like we had done in the previous several problems, it would be wrong. It's wrong because what we've just done in this very important step right here is we have divided by a negative. And in the event that you divide by a negative, you must reverse the inequality sign, and that changes quite a bit. So make sure you note that, put it in your notes so that you get those questions correct. And we'll get this. Notice how you may have gotten everything right. Not selected the graphs with closed circles. Fantastic. But look what happens here. I have to make a decision between C and D. And if I had not known or recalled or remembered to apply this rule here, I would be choosing C as the correct answer. When in reality, it should be D because I reversed the inequality sign. Make sense? Any questions about that? Any questions about your problem?
Can you help me with the last one?
The one before?
Yeah.
Sure, what's yours?
X over 8 is greater than -1.
Okay, what do you do to both sides?
Multiply by 8.
Excellent. All right, what happens to the left when you multiply by 8?
1x.
Or simply just?
X.
Good. What happens to the right side?
I canceled those out. That's where I think I messed up.
Well, you actually told me correctly. What's left over is x, because they do cancel out. Just like, as you can see here, you would have canceled out in previous sections. That's the point, right?
Yeah.
So you cancel them, they become 1, and you, like you said, you get 1x, and then I asked, well, or just x, like you said. That's it. What's left on the right?
-8.
Exactly. What's the sign?
Greater than?
Good. Here's your answer. Make sense?
Yep.
It's just like the one we did, just a different number. Okay? Good. Any other questions? All right. Number 15. I mean 16. There we go. All right. So let's go to our next one. And I'm not gonna, well, maybe I can. Doesn't really make a difference, but I'm not going to do the equal sign equivalent on this anymore. Okay, you guys get the idea. You understand that what we're doing right now is essentially the same thing as what we've been doing in previous sections. 8x minus 4. Okay, so if this was an equal sign, you would know exactly what to do. And it is the same thing that we're about to do here. I would move the 7x over to the left because I want both sides, well, I don't want both sides to have an x variable or a variable in it. So 8x minus 7x is just 1x or just x. Minus 4 is less than 6. What I've just done there is I've moved all the variables to the left. That means that this -4 is going to need to be added or moved to the right. All of these things, again, we've done before. And once that's done, x is less than 6 plus 4, which is 10, and there's your answer. Is that any different from the stuff we've done before? Not much, other than that inequality sign gets carried. Now, the thing that you need to ask yourself is, why did I not flip the inequality symbol on this one? Why did I not flip it? Why did it stay the same direction? Because you need to look at it and go, there was absolutely no division by a negative like we saw in the previous problem. So that's why the sign didn't flip. Only flip the sign if you divide by a negative. Okay, so the answer was x is less than 10. That means an open circle, and you need to go to the left. Open circle to the left, and that's exactly what happens if you select D. D, open circle at 10, less than, less than. Any questions? All right, let's go to 17. Another one. I'm going to leave this right here. Okay, now I am going to move my variables to the left. When we're dealing with inequalities, it's just generally a little bit easier for most students to always think of them moving the variable to the left. Get your variables to the left side. 3x minus 6x is a negative 3x. Minus 4 is less than negative 22. Great. So that is the result of moving the 6x over to the left. If the x's are on the left, that means this negative 4 is going to need to go to the right. And so I will add or do the opposite to that -4 to get it to move to the right. -3x is less than, and this is a very, very common place for students to make a mistake. -22 plus 4 is going to be a -18. Very easy to make a mistake there. Hopefully you got yours correct and didn't have too many issues with your signs. And now you can see why I left this one here. I'm going to have to divide both sides by -3. Why do I have to divide both sides by -3? Because I need to get that variable x isolated by itself. -18 divided by -3 is a +6. And what do I need to do? Reverse that inequality sign because of what happened right here. And that is the answer. Be very careful. Got to reverse the inequality sign. X is greater than 6. And so, which one do I choose? Not any with closed circles. It's got to be an open circle going to the right, which is my D. Open circle at 6, greater than to the right of 6. Got it?
Why do we have to put them on the left? Why couldn't we just have the variables on the right?
You could go to the right, but the question is, can you read it properly at the end? So for example, if you move your variables to the right, at the end, it would have looked like this. And would you have read that properly? I would have. But what does that look like initially? 6 is less than x, which is a little bit tricky to see, but it is still true. All numbers are bigger than 6. 6 is smaller than all the numbers. So it still states the same thing, but most students would do what? They'd see this less than sign and immediately cut the arrow to the left. That's why I recommend always move your variables to the left when you're dealing with inequalities. It's just a little bit easier to work with. But look, if you can see it and know what you're looking at, great. An alternative, if you want to, is if you move it to the right, at the end, you can just reorient it and just make sure everything is written correctly. Isn't this saying the same thing as this? Just moved around. And that is the same thing, just again, can you see it? Some can, some can't. I just minimize my chances of having an error. All right, let's go look at 18. All right, so now that you guys have seen just about everything, let's do it over here. Not my typical day of writing all across the board. It's tough when we got graphs. Here we go. A lot of stuff going on here, so let's see if we can tackle everything. 20x plus 4 is greater than, make sure you write your problem down correctly, 5 times, nope, 4x plus 1 minus x plus 7. Okay. Now, if this was a problem with just an equal sign, it would be a challenging problem, but certainly not one that you can't do. What would we do first? Well, there's nothing to do on the left-hand side. Can't simplify, can't open, can't combine, can't collect, can't do anything. That's fine. The right side, you can do some stuff. 5 times 4x is 20x. 5 times 1 is positive 5. Minus x plus 7. Why didn't I multiply 5 by these? Because they're not in the parentheses. That's nothing new. That is nothing new. That's stuff that we've done. Let's go and collect like terms, combine like terms. Nothing on the left, but on the right, 20x minus x is 19x. Positive 5 and positive 7 is positive 12. Does this look like something we've done before? Yes, it does. We've done many problems like this. And now we can move the variables to the left, move the numbers to the right, and then do exactly what we've done in all the previous problems with a graph. we're going to move the 19x over to the left, so I do the opposite of that. Subtract 19x. 20x minus 19x is just 1x, or just x, plus 4, which is greater than 12. And then I just have one more step to get my variable by itself. Subtract 4 to the right, and that leaves me with x being greater than 8. Why didn't I reverse the sign? Because there has not been any kind of division by a negative. And so my answer, so long as I didn't make a mistake, should be x is greater than 8. Good. And we know how to graph it by now. All of our answers should have open circles and should be to the right, and that should be B for me. Open circle, greater than to the right. Any questions? Anything I can help you with? I think the graphing side of things is actually quite easy for you guys now. We've done enough of those. Maybe the algebraic solutions to these inequalities a little bit tougher. Questions? Okay, let's keep on rolling. All right. I'll do this one, but I wouldn't put this difficult of a problem in there for you, but let's go do it. Let me see how much space I had on the previous one. I doubt that there's much. Okay, I can work it probably down here. Just to leave the other one there. Okay, so I've got x over 4 minus 7 over 2 is less than or equal to x over 2 plus 1. Look, the reality is that I would not do something really this difficult to you, but I want to do at least one of them so you can see it. And we did one like this in a previous section. I've got denominators of 4, 2, 2, and 1 if you want to look at it. You're going to multiply everything by your lowest common denominator. What would that be? A 4. So I would multiply 4 by the x over 4 minus 4 times the 7 over 2. Bring down that inequality sign. 4 times the x over 2, and then 4 times the 1. What did I do there? I multiplied what would have been the lowest common denominator by each of the 4 terms. This is hard. And look, again, like I said, I don't expect you guys, some of you are just not going to get it. This is not something, like I said in the previous section, that's going to make or break you this semester. Don't stress it, okay? But if you can get it, that's all the better. Now let's go cancel. You guys know how to cancel. 4 and 4 cancel, leaving you with 1 and 1. What is that? X left over from here. Minus 4 and 2 cancel. And so that's going to be 2 times 7. This is a little bit hard to see. I'll bring it over here in a moment. Less than or equal to, what happens here? They cancel. 2 becomes 1, 4 becomes 2, leaving you with 2 times x, or just 2x. And positive 4 times 1 is positive 4. This is really hard to see, so I'm going to bring it over here. I'm not going to do any work, I'm just going to bring it over, so that's easier to see. X minus 2 times 7, less than or equal to 2x plus 4. I hate that I don't have enough space to go straight down, but it's okay. All right, so let's go finish this, shall we? So this is x minus 14 is less than or equal to 2x plus 4. See how I did work this right here? And now I'm going to move things over. Subtract 2x over to here. X minus 2x is a negative x. Again, if I gave you enough time to work this out, this is stuff that you guys could do. This problem just seems really tough because of the fractions that get things started. Then I would add 14 to both sides, and I'd have negative x is less than or equal to 18. But once again, this problem just continues to be difficult. I need to get rid of that negative sign here by dividing by a negative 1. And so x, negative 18, and flip the sign. This is tough. And I'm going to put a star here because this star is what corresponds to that rule that once again got implemented or used. If you can get this problem right, I'm very proud of you. It's not an easy problem. There's so many tricky spots here. Greater than negative 18 is going to be B. Oh, what? Greater than or equal to. Sorry, closed circle. I'll pause there. If you have questions, happy to answer them. It's not an easy problem. If you got it, you should be very proud of yourself because it's actually a pretty tough problem. If you got that one right, it's awesome. If you didn't, I'm happy to try to answer yours. If you just want to give up, I don't blame you because it's not a problem that's ultra critical. Questions about 19? Anything I help you with? I'm going to roll to 20. Now, we will now look at double-sided inequalities. And I'm going to actually just put this first one right here into this zone. If I have negative 1 is less than x plus 2 is less than 6. Look how this one looks different than any of the problems that we've done up to this point. This is a double-sided inequality because there are two inequalities that will end up closing up a region, a lower endpoint and an upper endpoint. Now, if I were to cover this up right here, and we had that problem, and I said, hey, go solve it, you would subtract 2 from both sides, wouldn't you? And you would get x is all by itself and less than 4. Now, if I were to cover this up, and come over on this side, if I were to cover this up, it wouldn't look very pretty, but would you do the same thing of subtracting 2 to get x by itself? You would. And if you were to do that, negative 1 minus 2 is negative 3, and you bring down your sign, and that is how we solve a double-sided inequality. Okay? So in other words, you just do what you would do to the left to the right, and to the right to the left. You just make sure you do both sides. What you do to the middle, you do to the right and to the left. If you want to get this 2 out of the middle, you move it out to the right and out to the left. Now, if this is your first time seeing a double-sided inequality, very similar rules apply. If there are no equal signs here, then I shouldn't see any closed circles. I should only see open circles in my problem. These are both closed, not an option. One closed, one open. Quick question. If I had one closed and one open, what would that mean in terms of my problem? It would mean one of these has an equal and one of them doesn't. But that is certainly not the case, and not the case, and so A must be my correct answer because both endpoints, both of the endpoints are open circles, which means that both of these endpoints should not have equal signs on them. All right, questions about number 20? Anything I can help you with there? This is something new, so I don't necessarily expect you to understand it right away. Of course, if you do, that's fantastic, but if you have questions, ask. Okay. right, let's look at 21. We'll do it down here. All right, what you do to the middle to get the variable by itself, you need to do to both sides of the double-sided inequality. You should do the +1, do the numbers first. So I need to get rid of the numbers in the middle first. Don't get rid of the dividing here, get rid of the subtracted one, the numbers. Negative 28 plus 1 is negative 27. Now the negative 1 is gone from the middle. Negative 19 plus 1 is negative 18. Very good. Now, next, I'm going to divide everything because I don't want that 9 in the middle. I want that x to get all by itself. I'm going to divide that by 9. So I'm going to divide that by 9. Now I'm going to divide that by 9. Negative 27 divided by 9 is negative 3, which is less than x, which is less than or equal to negative 2. And now that's the answer. We did not divide by any negatives, so we don't flip any signs. Be very careful with your inequality signs. Look at what I did there. See how the problem is a less than and a less than or equal to? It needs to carry over. This is a mix of an open circle and a closed circle. So you got to be really careful with this. So easy to make a mistake. A and C are out of the question for me because these are both open, both closed. My answer has an open and a closed. Now, which one is it, B or D? Negative 3 to negative 2, not D. These are positive 2 to 3. B is the correct answer, negative 3 to negative 2. Okay. Questions about that? Anything at all that I can help you with? On it? Okay. It's done. You guys don't have to worry about that or that. That'll do it.